Hi everyone. Welcome to Chapter 5 States of Matter. In Chapter 5, there are 4 subtopics. First is 5.1. We will learn about gas. Next is liquid. The third one is solid. And the last one is phase diagram. So let's look at 5.1 gas. So here are the learning outcomes that you should achieve. So we will mainly focus in this video, we will focus on Boyce Law, Charles Law, Avogadros Law, and Combined Gas Law. So there are 3 states of matter: solid, liquid, and gas. From solid to liquid, it is a melting process. From liquid to gas, it is a boiling process. From gas to liquid, it is a condensing process. Liquid to solid, it is a freezing process. Solid to gas, we call it as sublimation. And from gas to solid, we call it as deposition. And you already learned all of this in SPM. So let's proceed. We will look at kinetic molecular theory of gases. Kinetic molecular theory of gases, we use it to explain the behavior of ideal gas. So, there are few assumptions that we will use to explain the behavior of ideal gas, and later in this subtopic we will also learn about the real gas, how they behave. So first, all gases are made up of large particle, we call it as molecule. Next, molecule that are far apart. So, the actual volume of the molecule is negligible. Negligible means it is insignificant as compared to the total volume of gas. So here we can say that volume of gas is the volume of the container. Next is the molecule in a state of constant rapid motion and in all direction. So your molecule, gas molecule, will move in random motion. So you can see here the molecule are moving in straight line but in random motion, and it can have the possibility to collide with one another, or it can happen to collide with the container. So you can see the molecule, some of them collide with one another, and then some of them will collide with the container. The molecular collision, we call it as perfectly elastic, means we assume that there are no loss of energy. There are only redistribution of energy during the collision. Next, we assume there are no attractive forces or repulsive forces between the molecules. So means the one that we learned before this is IMF, intermolecular forces. We assume that there are no intermolecular forces between the molecules. And next is the pressure exerted by the gas is due to the collision between its molecule and the wall of the container per unit area. So we can measure this later in Newton per meter square. This is the unit lah. And next is the average kinetic theory of gas molecule is directly proportional to the temperature of the gas in Kelvin. So means as the temperature increases, the average kinetic energy will also increase. So if you increase the temperature, means the kinetic energy will also increase. Next, let's have a look at the properties of gas. So from the shape, it will take the shape of the container. Okay, so depends on the shape of the container. For volume, the volume of the gas is equal to the volume of the container. Gas, you know, it is highly compressible, and the density of gas is much lower compared to liquids and solids. So gas, it can move freely and randomly. It is miscible, means it can mix completely with other gases molecule when you put in same container. Let's have a look at the concept of pressure and the units. So molecule of gas, we know that it is in constant motion. It will be frequently colliding with one another, with other molecule, gas molecule, or it can have collision with wall of the container. So in the collision, gaseous molecule will exert a force. So this force, we will measure it in force per unit area. So area, you know, it is in meter square, m to the power of 2, and force, we usually measure it in Newton. Okay, so per unit area means it will be this formula, and m-2. Or you can also use the unit of Pascal. The device that we use to measure is called as barometer. So here are the value that you need to know. So for you will usually kita akan guna 1 atm lah. Okay, so normally ini untuk ideal gas. Later we will see ideal gas ni apa. Ideal gas PV equals to nRT. So means kalau guna PV equals to nRT, pressure must be in 1 atm. Okay, kalau soalan bagi in other unit selain daripada atm, you need to do the conversion first. Okay, so 1 atm is equal to this value 101325 Pascal or 101325 nm-2, and all of this 1 Pascal we know that is equal to 1 nm-2. And if the question give you in mmHg, so it will be 1 atm is equal to 760 mmHg or in 760 torr. So 1 millimeter mercury is equals to 1 torr. So untuk unit ini, it will be given in your list of constant. The thing that you know is how to do the conversion correctly. Now let's look at the first law, which is Boyce Law. So for Boyce Law, it states that at a constant temperature, so highlight here the constant, at a constant temperature, the volume of fixed mass of ideal gas is volume inversely proportional to pressure. So if you write this thing, it will be V is inversely proportional to pressure. So V is volume, P is for pressure. So you can also write it this way, PV equals to K, which K is proportionality constant. Okay, so focus here. Okay, so from the relationship, if you increase the volume, pressure will be lower. So tengok di first diagram. So you can see the greater the volume, the lower the pressure. So if you change the volume, so if you lower the volume, pressure will be increased. Okay, so like this second diagram. So the less the volume, means less in volume will result in higher in pressure. Okay, so what if you have different pressure and volume? We will use this equation, which is P1 V1 equals to P2 V2. And what are these? P1 is initial pressure and V1 is the initial volume. So, untuk equation ni, you can divide it into, ini adalah initial ataupun before lah, the before punya condition. And then the second part, P2 V2 ni adalah P2 final pressure. So this part adalah final ataupun after. Okay, after you change the condition lah, change the pressure ataupun change the volume. And V2 is the final volume. Okay, so in this case, pressure and volume, it can be any unit because later on you will cancel it off. As long as the unit is same on the both sides. So let's say for example, P1 ini kamu guna unit ATM untuk pressure. So on the right hand side, pressure tu must be in ATM as well. So if the question give you in different unit, first thing first, you need to make sure it is same on both sides. So ini adalah Boyce Law. So highlightkan this equation. So untuk Boyce Law, if you have different pressure and volume, you must use this formula. Okay, so Boyce Law, it is constant temperature. Okay, so let's see the relationship in the representation of graph. So ini ada dalam your notes. And for the first one, okay, let's have a look at the normal graph. Okay, so ini the first one. Graph of pressure P versus volume. So you can see ini dia punya y-axis. Your y-axis is pressure, and then the x-axis is in volume. So you know that the relationship for Boyce Law, P is inversely proportional to volume. So maksudnya kalau kamu increase in pressure, volume will decrease. So ini adalah the graph representation lah untuk this one, the first case. And then if you want to plot the straight line untuk graph of untuk Boyce Law, kita akan guna pressure P. Okay, your pressure in one axis and another axis will be 1 over V because it is inversely proportional. So your equation, okay, untuk Y to form straight line, kamu perlu tulis equation Y equals to mx plus c. So in this case, kalau it cross to 0 here, so your intercept sini adalah plus 0. And then P, if you use P pressure for y-axis, then it will be Y equals to M. M is your gradient. And then 1 over V is your x-axis here. Okay, or it can be vice versa. Depends on you. Okay, so it can be 1 over V against pressure. Okay. Next, graph of PV versus pressure. So if you plot graph of PV versus pressure, you will have a constant pressure, a constant line here. So let's have a look at the example. So you have a sample of chlorine gas occupies a volume of 946 ml of pressure, at a pressure of 726 millimeter mercury. Calculate the pressure of a gas in millimeter mercury if the volume is reduced to 154 ml at a constant temperature. So untuk this question, you can see hint yang pertama adalah constant temperature. So kalau dia cakap constant temperature, you know that it should be Boyce Law. So for Boyce Law, okay, you must write this equation because you have initial and final value. Okay, so the first one is, ini adalah V1, initial pressure, and then you need to calculate the pressure of the volume, the pressure of the gas if the volume is reduced to, maksudnya daripada 946 ml, it reduce berkurang kepada 154. So, read the question carefully. Sometimes it can trick you. Kalau reduce to 154, maksudnya ni adalah directly you take it as volume 2. Or sometimes the question could be tricky. Dia boleh cakap volume reduce by, berkurang sebanyak. So, kalau macam tu, you need to do the maths lah untuk calculate the volume V2, volume final. So, untuk this one, okay, kamu just use this formula, masukkan the value and kamu akan dapat the final answer. Untuk this case, you don't need to change ataupun convert dia punya unit pressure lah, because you will give the final answer in millimeter mercury. So if you substitute the value, okay, you need to make sure both side, left hand side dengan right hand side mesti sama unit untuk volume and untuk pressure. Okay, so kamu akan dapat pressure final, which is the value should be 4,460 millimeter mercury. Okay, next question. So for this question, hint dia masih lagi constant temperature. So you need to use P1 V1 equals to P2 V2 since this is Boyce Law. So kamu akan dapat, so from the question, identify ini adalah V1, P1, and then ini adalah P2. So you want to find the final volume V2 equals to berapa. Okay, so untuk this case, just substitute the value and kamu akan dapat. So you can see here, kamu masukkan dalam formula, kamu akan cari V2, and then V2 is equal to 1299.9 milliliter. Okay, so kenapa kita perlu guna unit yang sama on left hand side and right hand side? Because you can see here, kalau kamu nampak dekat sini ATM kan. So on left hand side, P1 in ATM, P2 also in ATM. So barulah kamu boleh solvekan the equation. Unit dia akan cancel off and it will leave you with unit milliliter sahaja. So this is your final answer. And let's say kalaulah dia minta volume in liter. Okay, so barulah kamu convertkan lah. It depends on you. kamu nak convert before or lepas dapat final answer. So, read the question carefully. Next is Charles' law. Charles' law states that at constant pressure. So in this case, highlightkan apa yang constant it is the pressure. Volume of a fixed mass is directly proportional to its temperature. And ini yang paling penting, temperature must be in Kelvin. So let's say the question give you in degree Celsius, so you need to convert it to Kelvin. So the relationship will be V directly proportional to T and T must be in Kelvin. So kalau tidak, kamu kena tambahlah at 273.15 to convert it to Kelvin. Okay, so untuk the other way to write it, you can write V over T is equal to K, where K is the proportionality constant. Okay, next. What if you have different temperature and different volume? Okay, so the relationship will be like this. So ini adalah the first one, ini adalah initial, sama juga macam Boyce Law tadi. And this is the final. So V1 and T1 adalah initial, volume and temperature masing-masing. And then V2 dan T2 adalah the final temperature and volume. So you need to take note that temperature must be in Kelvin. So volume it can be in any unit, tak wajib convert pergi liter unless the question asks you. And you must make sure your unit must be the same on both sides. Okay, so untuk the graph, okay, you have two graph here. And you need to take note that at 0 Kelvin, we call it as absolute zero lah dekat sini. Okay, which means it is at 0 Kelvin, maksudnya it is at negative 273.15 degrees Celsius. So, relationship untuk graph, we can show in graph V is directly proportional to T. Means if you increase in V, volume, temperature also will increase gradually. Okay, so untuk example 1, you can see a sample of carbon monoxide gas occupies 3.20 liter. Ini adalah volume. And at 1 to 125 degrees Celsius. So ini adalah temperature. Calculate the temperature at which the gas will occupy 1.54 liter if the pressure remain constant. So you can see here apa yang remain constant, it is the pressure. So kalau pressure remain constant, ini adalah Charles' law. So ini adalah Charles' law. So means the relationship will be V1 over T1 equals to V2 over T2. So ini adalah V2, ini you want to find T2 berapa. So rearrange your equation to find your temperature final. And you need to take note, kalau Charles' law, temperature, if it is in degree Celsius, you must convert to Kelvin. So 125 degrees Celsius, convert pergi Kelvin, you need to add 273.15. So kamu akan dapat your answer 398.15 Kelvin. So barulah kamu masukkan dalam formula to find T2. So you will get the final answer, which is 191.6 Kelvin. Example, a balloon is filled with air which has the volume of 2 liter and at temperature of 27 degrees Celsius. So ini adalah volume initial and this is the temperature initial. So calculate the volume V2 at temperature negative 23. So ini adalah temperature final. If the pressure remain constant, so means ini adalah Charles Law. So Charles Law, V1 over T1 equals to V2 over T2. So if you substitute into the formula, you will get volume 2 1.66 liter. Okay, so we can prove that relationship untuk Charles Law is, dia punya relationship V is directly proportional to temperature. So if in this case you know that temperature here is lowered, okay, so kalau kamu tengok compare T1 dengan T2, T2 final temperature is lowered compared to T1 27 turun kepada negative 23, and you can see volume 2 V2 will also sepatutnya menurun. Okay, so you can see here final volume is 166 liter and the volume 1 asalnya daripada 2 liter. So next we will look at Avogadros Law. It states that equal volume of all gases at the same temperature and pressure will contain equal number of gas particles. So means volume is directly proportional to N. So N is the number of mole. Or we can write it as V is equals to K times N, where K is the proportionality constant. And then if you rearrange, dia akan jadi V over N lah. Okay. So V over N ini yang kita akan pakai later untuk different condition. Okay, so kita akan guna V1 ini initial. Ini adalah final condition. So means if you have different volume and different number of gas particles, so we will use this formula lah, Avogadros Law. So V1 over N1 equals to V2 over N2. Okay, so the volume occupied by 1 mole of any gases, which means the molar volume, will depend on its temperature and pressure. The molar volume of any gas at standard temperature and pressure, so at STP means 0 degree Celsius and 1 atm. So take note, highlightkan this thing. So at STP 0 degree 1 atm is 22.4 dm cube. Okay, so at STP maksudnya temperature tadi 0 degree kan, but you need to convert it to Kelvin. So dia akan jadi temperature equals to 273.15 Kelvin and pressure is 1 atm. So means kalau ada 1 mole of gas, okay, ada berapa molecules? 6.023 exponent 23 molecules. So bersamaan dengan equals to 22.4 dm cube. So ini kamu dah tahu before this lah. And the volume must be in unit of liter ataupun dm cube sahaja untuk this case lah. Okay, kalau soalan tu bagi in milliliter or you need to convert it to liter ataupun pergi ke dm cube. So let's look at the example. So determine the volume of hydrogen gas obtained from the reaction of 6.5 gram of zinc and excess of dilute sulfuric acid. So zinc plus H2SO4, ini in excess. You will get the product of zinc sulfate plus H2 gas, hydrogen gas. Okay, so untuk this question, you know that pressure and temperature will be kept constant. Okay. So as I mentioned earlier, if your mole is 1 mole, so volume, okay, since ini dia cakap at a standard temperature and pressure at STP, so volume dia mestilah 22.4 dm cube. Okay, so from the equation we know that 1 mole of zinc will react to form 1 mole of hydrogen gas. Okay, so berapa mole dalam this reaction kita kena kira lah. So mole of zinc in this, dia akan jadi 6.5 gram over 65 equals to 0.1 mole of zinc. So if you have 0.1 mole of zinc, so you will also have 0.1 mole in this case of hydrogen gas. Okay, so untuk this question, use this formula V1 over N1 equals to V2 over N2. So you will get your answer as V2 equals to, okay, so since you already know it is 0.1 mole of zinc will produce 0.1 mole of hydrogen gas. So ini adalah dia punya N2 0.1 and V2, we want to find V2. Okay, so you substitute into this formula, kamu akan dapat V2 final volume 0.1 times 22.4 dm cube. Okay, kamu akan dapat your answer as 2.24 dm cube. Let's look at general gas law. So general gas law ni apa? It is a combination of Boyce Law and Boyce Law. So Boyce Law we already learned. The relationship is volume is inversely proportional to pressure, and we know that mole and temperature we kept it as constant. So for the next one is Boyce Law. Boyce Law is volume is directly proportional to temperature, and here we will keep constant and then P, pressure. So if we combine these two, kamu akan dapat combined gas law, which is V is, okay, inilah dia punya relationship if we combine it, or we can rewrite, okay, nicely into one side. Okay, asingkan into one side, dia akan jadi PV, okay, T ni bawa ke bawah, okay, so dia akan jadi like this, and equals to KK adalah proportionality constant lah. Okay, so untuk your combined gas law, kamu akan dapat PV over T. But then, if you have initial dan final, okay, kita akan tulis macam ni lah, kalau ada dua condition. So, pressure initial times volume initial over temperature initial is equal to pressure final times volume final over temperature final. So kalau combine gas law, kita akan guna this equation. So let's have a look at the example. So you have gas initially, the volume is initial volume, and then you have initial volume, initial pressure, and initial temperature, and it will undergoes a change so that a final volume will be 1.7 liter and final temperature will be 42 degrees Celsius. Okay, so in this case ini adalah your volume initial and ini adalah your pressure initial, temperature initial, volume final, temperature final. So you need to find the final pressure. So in this case, kalau dia tak cakap what kept constant, biasanya kita akan guna P1V1 equals to T1. P1V1 over T1 is equals to P2V2 over T2. Okay, so in this case, kamu just substitute the value. So make sure you substitute correctly, and then untuk temperature, don't forget to change from degree Celsius change to Kelvin, and then substitute into the equation, and then you will get the value untuk final pressure will be 1301.86, and the unit untuk pressure will be in torr.